very much, and thank you everybody for being here. Well, as Gary was saying, my presentation will be on wildlife in the city, the effects of corridors on wildlife in Tucson, Arizona. Now, wildlife in the city. Pretty much every city within the world has wildlife to some extent or another, whether it's birds or in our case, we have a nice wide variety of animals that you'll see potentially all throughout the city, from javelinas, raccoons, bobcats. Now, over 80% of Americans live in urban centers now, and that actually comes from a 2010 census data. And I believe that it's actually increased by a few, like about 1% since then, or at least estimated. It'll be interesting to see the actual numbers once the 2020 census is finished up. Now, because more people are living in these cities, they need places to live. And because of this, you end up getting urban sprawl. And you have more and more people living within urban areas, spreading out into suburban areas. And with this sprawl, you end up having what's known as habitat fragmentation. Now, these animals, these wildlife, they need habitat. They need it for food, for shelter, water, a place for them to raise their young. And oftentimes, they got to travel between different habitat locations. And so I decided when I was thinking about, okay, they're using some kind of corridors. And so I thought, well, the first kind of corridor I was thinking about is a wash. But then obviously any type of area that's going to have lower human traffic is probably going to be like alleys, culverts and bridges, some way of passing underneath busy streets, empty parcels of land that don't have people living on them. So looking at all this, I was considering my research question. Do wildlife corridors reduce the negative interaction between humans and wildlife in the city of Tucson? Now, there is wildlife all throughout our city, and I know everybody has one story or another. It could be something as simple as just seeing a bird in your backyard or seeing a javelina run across the road. To answer this question, I'll give you my outline here. Well, obviously, I already gave you an introduction to wildlife in the city. I'll be talking about where I got my data from, the Tucson Wildlife Center. We'll look at the study area real quick, the methods that I used to get to, and then my results, and then conclusion from my results. So the Tucson Wildlife Center, I actually started volunteering there at the same time that I began this program last year. And I started with wildlife care, and pretty quickly on, after also helping with some rescue and such, I realized that wildlife is being found everywhere in the city. Whether it be birds, somebody having a raccoon in their attic, ring-tailed cats, all different sorts of animals all over the place. The Tucson Wildlife Center, they came into play because these two people, Lisa Bates and Peter Lininger, that actually decided to, help animals because there wasn't a wildlife hospital anywhere around, like the 8 neighboring counties. Now, we'll go into a study area. Now, in the city of Tucson, it's the second largest city in Arizona, population just over 520,000 people, about 226 square miles. And I know that everybody's probably fairly familiar with the city of Tucson. Here's the reference map to kind of give you an idea of where it exists within Pima County, within Arizona. And I'll be looking at wildlife, specifically terrestrial wildlife that can walk, that needs to walk to actually, be able to use those corridors. And so I'll be looking within the city limits instead of some of the neighboring townships and such. So starting my methods, I had to acquire the data, and that meant getting in contact with the Tucson Wildlife Center. Now, Pima County and the city of Tucson, that's where I got my additional layers for the city of Tucson, for culverts, alleys, washes. Now, with the Tucson Wildlife Center, you actually look at the wildlife data that they had. It was all in a CSV file format. And so I actually had to take where was reported wildlife was being found and then be able to somehow transfer that into points onto a map. And so I used the geocode addresses geoprocessing tool. Now, once I actually made that, it's going to show all the wildlife within 8 counties. And so I clipped it down to within the city of Tucson. And then I also had to go into another portion of the fields that gives 4-letter codes for wildlife and specifically choose animals that I know actually, have to walk around. They can't fly. So then after I got my data condensed and I merged wildlife corridors, and I took what the aforementioned considered corridors, the alleys, washes, bridges, culverts, and then I merged them all together into one single layer. And then I began running different tests, kind of determining okay, is there some kind of trend? Is there something noticeable going on with the points that I have? So I assessed the actual wildlife points themselves, and that's where I used my average nearest neighbor. And then I looked at kernel density for a better visual representation. And then after that, I tested the points against wildlife corridors. And I chose the near tool 500 feet because that was just underneath that was the largest. It was a nice round number, and that incorporated all the wildlife within that area. And just giving you another look here at what kind of data I would utilizing per the different analysis tool that I had. For average nearest neighbor and kernel density, I used just the terrestrial wildlife points. The near analysis, hotspot analysis. Well, near analysis provided me with the field that I needed to be able to utilize hotspot analysis, and then my spatial autocorrelation, the global Moran's eye. So with the results, first starting off, you see here that we have average nearest neighbor, and you can actually see from low z-scores and the low p-value that this actually disproves the null hypothesis that is just random distribution. That is, in fact, actually with the low z-score in implying clustering, and that it's a significant clustering that's being shown with the wildlife points. And here's an actual map to show you between the 2 years of information that I was actually get for my data. In 2018, for the most part, the high, while you notice that there's a fair amount of clustering throughout the city, the highest density is actually here off to the east, and this is actually Houghton Road here. And so it's just east of Houghton Road, up around Broadway, I believe. That's either Broadway or Speedway. And then in 2019, you notice that it actually kind of shifts west and onto Houghton Road. And then there's actually quite a few more of these points throughout here. And actually, this kind of line of clusters, I believe, is also Craycroft Road, kind of going down onto Davis-Monthan Air Force Base. Now, to get my distance from corridors, like I mentioned before, I use the near tool. And with the near tool, you can actually see here off to the left, I have this map here that shows you each of the points where the wildlife, the terrestrial wildlife is found. And then my merged corridors layer, which incorporated, like I mentioned before, alleys, washes, empty parcels of land. And you notice that these corridors stretch all throughout the city of Tucson. And it's interesting to notice that these empty parcels of land tend to be off to the west and kind of the southern Tucson. And so you may notice that there's not as many of these points actually being found over there. The mean average distance for wildlife being found in 2018 was right around 152 feet away from the corridors, with there being a notable amount of them being closer. And then also for 2019, the mean average distance, you notice that there's quite a few more points here, and then the mean distance is 137 feet. So going on to my hotspot analysis, utilizing this this field I was able to create from the near analysis, you'll actually see I actually took I did a fishnet grid overlay of the city of Tucson, and then I did my hotspot analysis utilizing the distance of wildlife from corridors, and then I aggregated those points, and that's where you get these 1 square mile blocks with the points inlaid on top of that. So you'll see just what you kind of saw with the kernel density earlier, this higher density of wildlife off to the east, but you also notice that you have these hotspots here within the city of Tucson, and then in between that you have these cold spots. Now the cold spots are actually referring to wildlife that's found farther away from corridors, whereas the red, the hotspots, refer to wildlife that's found closer to corridors. And after showing you that visual, I decided to also run the global Morans, the spatial autocorrelation, and I got the high positive z-score along with a low p-value, which also rejects the null hypothesis that it's random distribution, and it's actually showing that the distance from these corridors is actually affecting the clustering. So in conclusion, we do have high clusters of injured wildlife near corridors that are found in eastern Tucson along Craycroft Road and in Davis-Monthan Air Force Base, as well as smaller clusters all throughout the city, with the least amount of clustering being noticed around South Tucson amongst vacant parcels. Now, it's interesting to think that within the vacant parcels, there's not reports of these injured wildlife, which is what these points really are, is reports of a sick and injured wildlife and where they're being reported. Now, that could also mean that there's not people there, so they're not going to be reported, but it could also mean as well that, you know, without people being there, there's less chance of wildlife having some negative interactions and potentially less risk of injuries. Now, another thing I can look at also that can be looked at with this particular data, with this study, is that there is, you know, look at more than just 2 years worth of data. I only had 2 years to work with that I was actually spatially referenced. Also comparing it to a similar sized city that maybe has less corridors. Also looking at non-injured wildlife data, if it's possible to find something like that. The only thing I could think of off the top of my head is like using some sort of open source system like eBirds, but that is looking at just birds in particular. So if I was to say do a study on terrestrial wildlife and I was looking at birds, and it'd be just quails and roadrunners. And so you could just look at 2 specific species and compare healthy to non-healthy occurrences there. I could also assess individual types of corridors. Instead of merging them all together into one large set, you could see whether certain corridors, there is more of a correlation between those corridors and others. And here's my data sources. Any questions?